All right, we are in part 4, unit 3.1, circles. Getting close to the end. Number 31, you're given the equation, you're finding the center and the radius. So remember to change the signs. So x minus 2 squared, that's a positive 2 coordinate for the x value of the center. And since that's just y squared, we know that y value will be 0. The radius is the square root of r squared, so the square root of 10. I don't need a decimal, but it's 3 point something. Number 32, write the equation whose center is -5, 8, and whose radius is 9. So we know we're going to change the sign. So x plus 5 in parentheses squared plus y minus 8 in parentheses squared. We're given the radius is 9, so we want the radius squared. 9 squared is 81. 33. We're given the area of a circle is 81 pi square inches. We're asked to find the radius, diameter, and circumference. So I'm going to write above this one. If I know area is pi r squared, and I know that's equal to 81 pi, just divide the pi's off both sides. You get the radius squared is 81. When you take the square root, you know the radius must be 9. You know the diameter is twice the radius, so it's 18. And hopefully you know the circumference is pi times diameter, or 2 pi r. Regardless, you should get 18 pi here. We know that the radius is in inches, the diameter is in inches, and the circumference is in inches. Only area is in square inches. Okay, number 34. A circle has a circumference of 64 inches. Find the radius, diameter, and area. So my equation for circumference is pi times diameter, and that's equal to 64 pi. So if you divide off pi, you get your diameter is 64. Your radius is half of that, so 32, and your area is your radius squared times pi. So 32 squared is 1024. So your area would be 1024 pi r squared. All right, and again, that area is in square inches. Everything else is linear in inches. 35, a circle has an area of 78.540 square inches. Find the radius, diameter, and circumference. This is just like question 33, except it's not in pi notation. So when you set this equal to pi r squared, this time you have to literally divide that number by pi. So use your calculator. You're going to type in 78.540 divided by pi. Use the pi button. Don't use 3.14. And you get 25.00005846. So we're just going to round that to 25. So we know the radius squared is 25. Take the square root. The radius is the square root of 25, or 5. The diameter is twice the radius, or 10. The circumference is the diameter times pi. Since this was given to you in a rounded form, not in pi notation, I would expect the answer for the circumference to be the same way. So 10 pi is 31.416. Oops, so 31.416. And again, all of those measures that you just found are in inches, only area is square inches. Number 36, a circle has a circumference of 56.549 inches. So again, this is not in pi notation. It's not in terms of pi. Pi's been multiplied through. So when we say 56.549 equals pi times diameter, we must actually divide that number by pi. So 56.549 divided by pi, we get 18.000 and some change. So we'll round that diameter to 18. So that's our diameter. Our radius is 9. Our area is pi r squared. So I need to take that 9 and square it to get my area. So instead of writing 81 pi, we'd want to write in 81 times pi, which is 254.470. So 254.470, and that's in square inches. The rest are in inches. Okay, 37, we are finding the arc length and sector area of the shaded sector below. Round your answer. Do not leave in terms of pi and show all work. Okay, so let's do arc length first. To do arc length, we know we're going to set up a ratio of 45 over 360 equals the arc length over the circumference. The circumference is pi times diameter. So if my radius is 3, my diameter has got to be 6. So my circumference is 6 pi. But since we're not leaving it in terms of pi, let's just multiply that through right now. And we'll use 18.850. So 18.85, since that 0 is not very important. All right, cross multiply, we get 360 times x, which is going to be our arc length, is equal to 18.85 times 45. That's 848.25. When we, my pen's dying. It's just a comedy of errors today. When we divide that by 360, we're left with 2.35625. So 2.356. That's our arc length. Okay, hopefully you can see that I switched to pencil. All right, the sector area, I'm going to call that y. I'm going to set my proportion 45 over 360 equals x over, or sorry, y over my area. Area is pi r squared. So in this case, our area is 9 pi. Again, we said we want that decimal answer, not the, in terms of pi. So I'm going to use 28.274. 274. All right, I'm going to cross multiply and get 360y equals 28.274 times 45, which is 1272.345. Divide both sides by 360 to find y. Voila. Y is equal to 3.534. 3.534. Okay, number 38. Given that ray AB is tangent to the circle, find the measure of x in the diagram below and show all work. We must remember that when something is tangent to the circle and there's a radius that intersects that ray line or segment at its point of tangency, they make a right angle, the radius and the tangent. So we have a right triangle, and if we re-sketch it over here, it's like we have a right triangle where we know the hypotenuse is 6 plus 8, or 14. This leg is also 8 because the radius of that is 8, and then my unknown is x. So all we really need to do here is the Pythagorean theorem. 14 squared minus 8 squared gives us x squared, and you can actually write this into your calculator as the square root of 14 squared minus 8 squared. All right, so the square root of 14 squared minus 8 squared is 11.489 approximately. So 11.489. All right, moving on. Oh, some of these are easy, some of these aren't so easy. 39 is an easy one. Given that points D and B are both points of tangency, find the value of x in the diagram below. We see that those two tangent segments come from a common external point. So these segments are equal. So 7x minus 29 equals 3x plus 15. I subtract 3x from both sides. I get 4x minus 29 is equal to 15. And add 29 to both sides. 29 plus 15 is 44. So I get 4x equals 44. When I divide off that 4, I can see that x is 11. Excellent. Pun intended. All right, 40. Find the values of x and y. Oh, I'm going to have to go in a second. We'll see if we can at least finish this problem. The values of x and y. So we have two inscribed angles that open to the same arc. So if 34 is inscribed, I know x, that arc, is going to be twice that angle. So x has to be 68 degrees. Because y intercepts the same arc, y is also 34 degrees. That one's not bad. 41, I think we got time. 41, we are finding x, y, and z. Y is going to be this angle that's inscribed, or sorry, this measure of this arc that's intercepted by this inscribed angle. So it's 49 times 2, which is 98 degrees, just like the boy band from the 90s. All right, to find Z, well, actually, we could find X first, doesn't really matter. If this arc is 160 degrees, X is half of that, so X must be 80 degrees. And then lastly, to find Z, we could either find this angle in the triangle and double it, or we could just subtract these two from 360. I'm going to do the latter. So 360 minus 160 minus 98, we're left with 102 degrees. So that must be 102 degrees, meaning that is, what, 51 degrees if you were to find that. Could have done it that way as well. Last one. We'll see if I'm late to my own class. Number 42, you're finding the measures of A, B, C, and D. We know that in a quadrilateral, these opposite, when it's inscribed in a circle, the opposite angles must be supplementary. So to find A, we just do 180 minus 111, and we get 69 degrees. Those must add up to 180. Same with B, 180 minus 95 is 85 degrees. Must add up to 180. So now it gets a little trickier. We did some like these in class. If I look at this 95 degree angle and I double that, I'm going to get 190, meaning this big arc, that's C plus 79, has to equal 190. So when we subtract 79 from that, we're left with C equaling 111 degrees. And then when we do the same thing over here, angle, let's see, A, we said is 69 degrees. When I double that, I get 138. So C plus D is 138, and we said C is 111. So 138 minus 111 is 27 degrees. Not sure that's to scale, but hopefully that's correct. Let me know if you think I made a mistake, and we'll be on to the next page soon.